Hey guys, today we're going to progress beyond intersecting lines to a more specific type of intersecting lines, which is parallel lines intersected by a transversal. All right. So to get our vocabulary right, this guy right here is a transversal, the sort of a slanted line right there. That's a transversal. And we are going to go ahead and say that these two lines, these two horizontal lines, are parallel. Now, every relationship that we're going to build is because these two lines are parallel. If these lines were not parallel, then we could not establish most of these relationships. All right. So the first one is, and here's your terminology, is that corresponding angles are going to be congruent. So basically, you need to understand these 6 labels for angles: corresponding, alternate exterior, vertical angles, same side interior, alternate interior, and same side exterior, which I won't spend time from the video to go over those. Those are in your notes. But you need to basically know what does this mean about the relationship between the two angles? Does it mean that they are congruent? Does it mean that they are supplementary? Or what does it mean? So here are the type of exercises that you could solve with knowledge of these types of angles. So once again, you see transversal T and you see parallel lines M and N. And notice how the problem says, given that M and N are parallel, that symbol right there means that they're parallel. Find the value of X. So this can only be found because they are parallel. All right, so what we have right here, X and 132, their relationship right there, well, they're not same side, they are exterior, so we're going to call these alternate exterior angles. And we can say that X is equal to 132 degrees. A lot of times you can sort of eyeball these. So the relationships are pretty straightforward. Another relationship that you could establish is, if this is 132, then the corresponding angle to 132 is this guy right here. So that one must be 132. That's corresponding. And then X and 132 are vertical. So that means that angle A is congruent to angle B, which is congruent to angle C. All right. So it's kind of by a transitive property right there. Okay. So X equals 132. All right. And we progress to the next example. All right. So if we kick it up a notch, here's basically same type of problem. However, now we have expressions. All right. So remember, the important thing is to establish the relationship. All right. So we have 7x minus 9 and 5x plus 9. Now, once again, I like to make this relationship 7x minus 9 should be also the same as this one, 7x minus 9. It is equal to that congruent, to that corresponding angle. All right. And 7x minus 9, we know, is not going to be equal to 5x plus 9, but they will be supplementary. So you can set up the equation 7x minus 9 plus 5x plus 9 equals 180. Solve this equation. 7x plus 5x equals 12x. Negative 9 plus 9 gives you 0. So 12x equals 180. Find how many times 12 goes into 180. And that would be 15 times. So X equals 15. All right. And we continue. And our last example is, what if we have this transversal and we have multiple variables to solve for? All right. Once again, we're given that the two lines are parallel. That is actually important. We're going to later get on into some proof statements for that. All right. But we can once again start with the fact that 6x minus 5 and 3x minus 4 are going to be supplementary. All right. So start with that reality, and you will have 3x minus 4 plus 6x minus 5. All right. Because this is addition, I didn't bother with the parentheses. And that should be equal to 180. So we have a 3x plus 6x, that's 9x minus 9 equals 180. All right. And so we find that X equals 21. We can substitute back into it to find that 3x minus 4 is actually equal to, that angle is equal to 59, which means that its supplement, Y, will be equal to 121.